All right, hello and welcome back to American Diesel. My name is Joseph. Today's period of instruction will be on fuel systems. Diagnosis, we'll just go over it. So we're going to go over fuel systems, what they are, why they're used, how they're used, and it's more than just ignition. We're going to talk about pressure and flow. Flow being the how much and pressure being the how hard. Talk about suction side of pumps or fuel systems, discharge side, pressure side of fuel systems, filter restrictions. We'll talk about mechanical pumps, electrical pumps, high pressure common rail a little bit. I'm going to save a Huey class to do on its own because I need some diagrams to show a little bit better, but that'll be the only thing we don't cover today is Huey, but we will cover a lot of the fundamentals of it. As far as diagnosing the injectors, I do need to show you a display. And then personal experience, some tools, and the most common problems. I'll also show you a tool that I have met one mechanic in all of my career who uses it, but it makes me a lot faster than having to do all the manual pressure gauge readings, and I will explain that. So, where do we start? We start with page 1. We're going to talk about fluid dynamics, and we're going to talk about the difference between pressure and flow, because I think that is one thing that's often overlooked. And so when we talk about the pressure, we're talking about the amount of force being built inside or pushed upon the diameter of whatever delivery system, whether it's a line, a hose, or a pump, or whatever. And then as far as flow flow is talking about the volume or how much, right? So that's going to, so let's say we have a 4.5 to 9 pounds of pressure pump. That's going to operate from that 4.5 to 9. It also operates that 4.5 to 9 at the same amount of gallons per hour. It's 32 gallons per hour for that pump. This is for a Humvee. It's for a lift pump, for a mechanical type of direct injection pump. But the point I'm trying to make here is if I was to open up this fitting to a bigger diameter and make this pump bigger so it could accept more volume, that would mean that the gallons per hour would increase, but it might not increase the actual pressure. So we want to be mindful of the difference between the two, and the most common problem I find where this is something that's not perceived of well is in pressure drops across filters, because we might be able to achieve pressure on the discharge side of a pump, but that filter keeping the from only pulling so much fuel will at some point depreciate the operation of that engine. It will have power complaints. And how do you find this? I'm going to show you. But I first need to explain a few more things. So one thing about fluid dynamics that we need to understand is you can compress air, but you can't compress fluid, right? So a hydraulic cylinder, there's no air in that cylinder. Fluid goes in the cylinder from the ballast or the delivery hose or wherever it's fed from a solenoid on a pump. Pump's generating the pressure, solenoid varies the pressure, and that operates the cylinder at a certain varied amount of pressure. So when you pull the lever in the bulldozer or whatever, you get hydraulic cylinders that are fed pressure slowly or quickly. So the same thing is happening inside of a fuel pressure system, and that's why I talked about it. See, the fuel pressure systems have more than one purpose. I'm going to talk about one of them to start. It's used for ignition, but it's also used for cooling. So the lubricity, the oil content inside of that creates a slip between the two metal parts. Sulfur, ultra low sulfur fuel, does not have the same amount of slip or lubricity inside of that fuel that it used to have. CP4 pumps have come up with a judgment, I think, with Dodge, Cummins, because they knew that pump wasn't supposed to be operated on ultra low sulfur fuels. Those clearances are very tight, and the amount of friction inside of there is a lot if you're not giving something to seep into those rollers so that it has some slip. And all the other internal components. And it's used as a hydraulic fluid for injectors to open, intensifier piston popping off. So some guys you've seen the old injectors, the pencil type, where you pull the lever on that tool and that's a hydraulic operation, right? So I'm pushing down and pushing down and pushing down. Finally, I overcome the spring pressure and I release. So say I have a direct injection pump with a line going to an injector, and each time it mechanically rotates, it builds pressure in each one of these, what they call barrels. They're little tubes, 6 of them, 6 barrels, and each barrel will have a delivery on the backside of that pump. Now that's an old pump, but let's think about a new one. if we talk about a Series 60 injector, where the solenoid is actually closing off fuel from getting out. And as the rocker arm comes down on that injector, it's building pressure, just like that pump to the injector. It's just all happening in one. But if we couldn't do that with air, right? We couldn't operate that injector with air. And the reason why we're using fuel to do that is because then I can make sure that those pressures are only coming out at a certain time. You understand what I mean. Okay, so quality of fuel is a priority. A quart of coolant inside of 1,000 gallons of fuel is enough to hang open every injector you feed that fuel with. Why is that important? Because when you have injector cup failure and you have a mixing of coolant and fuel, you need to take all the fuel out of it. Just as a personal note, it is considered a hazmat and very hard to distill the both of them. So it costs more per barrel. Make sure you include that in your price if you're going to recover all the fuel from all those tanks, that you include a hazmat price. That's just a side note. It's not really that expensive to get a barrel of fuel and oil separated, right? But coolant's more difficult because the water and the oil will form little water droplets. Those water droplets go through the injectors. And I don't know how many injectors I've taken them apart, and you can see clearly inside there's a piece of speck of rust, and then the injector with a jeweler's loupe, you can see where it scuffed it. And keep in mind, these injectors are in the millionths of clearances, some of them, especially in the high pressure common rail stuff that's pushing 30,000 pounds of pressure. If it had that much pressure going to it and it had a gap that was a couple thousandths big, it would lose the volume of fuel being delivered and pressure would drop, but also, you'd have other problems. So keep in mind that everything has to be super tight. Every sealing surface has to be super tight. Everything is an opportunity for error or a point of failure on a fuel system, especially on the suction side. The only thing I'm going to talk about after this is that everyone knows that when you get an injector, brand new, it's different than an injector that's been remanned. On the top of an injector, a modern injector, you will have a calibration code. We talked about that in the misfire class. The reason why it's pertinent here is because you need to know that without that code, when they rework that injector, when they ping that coil on that injector, it's supposed to atomize at a certain time. That fuel trim code is the timing for that specific injector. So on a CAT, you used to have to load software on a disk and find your injector code and then load that one into the ECM, so the ECM knew how to operate that kind of a trim code. This is really crucial because fuel is being atomized at microseconds, guys. It's not like the old injection strategies. It's much faster. That's the reason why we're able to do everything we can do now with the engines. And for fuel economy, if you think about old big semi trucks that used to push 1 to 3 to 5 tops miles per gallon, now we're looking at some engines generating 8 to 12, no problem. That fuel efficiency comes from the accuracy of the injection strategy, timing. So I can advance or retard timing and get the best injection strategy that I can for peak combustion, which we talked about that with the misfire class. So injector cal, pressure, can compress. So keep in mind two things. When we talk about suction for some pumps, especially low pressure pumps, suction qualities are not great. So if I'm losing prime or losing, let's say that I have a straw here and I put it in a drink and I put my finger over the top, all right? As soon as I pull it out, there's fluid in this line. Well, the fuel lines on all of big semis, they stay with fluid in them. So if you're losing that prime, it might be because this connection right here is just loose, and air bubbles, gravity, will send all the fuel back to the tank, which will give you an extended crank hard start. Okay, it will start, but it will take a long time to build that fuel prime back up. So if I know that, and I have like a big displacement pump, always make sure it's primed. Even a water pump, a big huge pump like that, you have to fill them up, right, to prime them, because they don't suck until they push, basically. Yeah. So I would say that extended crank causes harm to the starter, to the batteries, to the cold start. As far as like cold starting them, it's very hard to start an engine cold because you're sucking cold oil. It's really low RPM. It's probably not going to build a lot of oil pressure working at that much RPM, so you're not going to get much lube in the circuit. These are all things to consider, and I don't know. I felt like mentioning them because I think that a lot of people don't really perceive a fuel as probably fuel and air. If I was to pick between the two, it would be fuel. For any diesel engine, as far as poor operation, always start with fuel. All right? Because a lot of times when you find, unless it's like a black smoke, low boost fault code, when you're dealing with mechanical fault codes, almost 100% of the time, they're going to be something in the filtration. And because everything else is being measured in red really well. So that's when we get into volume, is that filter plugs so much that it can deliver pressure at really low demand, but it cannot deliver pressure at really high demand. When I need a lot of volume, it cannot keep up because it's hindering the amount of flow to the pump. So that's when we get into the drivability and performance issue of this channel, is that I want you to be able to take an engine and make it operate at its peak performance. So if I'm asking, say on a high pressure common rail, I'm asking 30,000 pounds at the very top end when I'm under full load and I've got 30 pounds of boost, I have to have the volume to keep up with that 30 pressurized pounds of boost in that cylinder. So a few things to consider. Aerated air-equipped lines. So let's say you've all seen the black lines where this will be the fitting on the end. Obviously it's like a number 4, number 6, and whatever, but it has a flare and a bevel, right? If this screw comes off just a little bit, it will unseat that bevel from the fitting on top of it, and it will suck air. Another thing to remember about those air-equipped, those black steel braided lines, is that they will perforate with little bitty needle holes that you cannot see, and they're not wet from leaking fuel out. It's the only time you'll really find that. We'll go further into that, but keep in mind that that's the point of failure. But what you do is you cap them off and pressurize them you pressurize them with air, and you can find the leak. But the easiest way we'll go into later about defining whether or not it's in the truck or part of the engine. So talk about banjos. Banjo fittings, like this is a banjo fitting, right? I put that in there. There'll be a washer on one side, washer on the other, and then as I tighten it down, those washers seal the gap. Do not reuse those washers. They will have an indentation inside of that copper washer that you will not be able to seal that washer again, and it will suck air. Now, a lot of these things don't suck a lot of air until you get to high volume demand, and then you're really pulling in some air, and now it really makes a difference between your common rail can't keep the 30,000 and you can only get to 23 because you can compress air, but you can't compress fluid. So it's sucking the air, compressing it. It's, it's doing the job of moving it, but it's not fluid volume. So O-rings on anything, right? Whether it be a JIC fitting at the bottom of a fuel filter bowl or a fuel filter head, any O-ring is enough to, even a little slice on an O-ring is enough to ingest enough air, especially over a couple days of sitting, for that thing to have a hard time priming and starting, or keeping prime. So next one is, we're going to talk a little bit about pressure and flow as far as like a lift pump. A lift pump that is feeding like a 5.9 Cummins engine, right? That lift pump, that transfer pump is feeding that bigger pump. It's like an assistant to that pump. That's a really good example of pressure and flow, because a lot of times when you're asking all day long, it'll be at 30 pounds. But as soon as you put the engine under a load and you drive it, it'll drop all the way down to 10. Why is that? Because it can't keep up the amount of flow, but it does pressure, right? So I won't know if the pressure is maintainable until I start using what fuel is available as far as flow. I'm not beating a dead horse here. This is something I've watched guys bury their damn careers on, and I wish, you do have to think of them so differently. And really, fuel is the only incident where or place where you come into contact where that really matters, where or even hydraulic fluid, flow and pressure, they really matter. So we're going to talk about highly expensive repair due to poor filtration. So if I suspect that I'm getting air, because say I have a diagnostic where it's an extended crank to start, right, or hard start, it could very well be that I just I have a filter that has a hard time getting fuel through it, and I change the filter. If I do a poor job of changing the filter now, I've made a problem that I'm going to have to later on try to diagnose. So in my diagnostics, I would rather check the filter. The way to do that is by checking the 2 ports on top of the filter head for amount of restriction. So the way I would do that, I would get an 1/8 inch fitting, all right, put it on one side, take a pressure or a vacuum reading, take it on the other side, take a vacuum reading, pressure reading, whatever it is that the specs call for, but that's going to tell me what the inlet is from the tank to the discharge from the filter, or the other side where I'm getting fuel now to the pump from the filter. It's all suction though. So the difference between, obviously, we have the remotely mounted pump where we're running a gear-driven pump is a lot different than the automotive application where I have a pump inside of a tank that doesn't have to suck anything. It just pumps. The one up here has to pull through all these different fittings and all these different banjo fittings and all these other places where there are opportunities. So if I'm going to diagnose that, I need to start introducing the clear hoses, right? From on a Volvo, let's say. And keep in mind that when I'm introducing my test equipment, I'm not going to limit the amount of diameter of the flow, right? So I'm not going to take and try to read the same flow off of that I would off of this. They're both banjo fittings with the same exact head, but the flow would be different, right? Because the hose diameter is what determines flow. So these banjo fittings, you can get them at, all kinds of different fitting stores, like hydraulic stores usually have a lot of these fittings, but you're going to want to start acquiring all these fittings as you go along and keeping them and separating them, because this is really what makes a guy fast and proficient, is to have the right test equipment. And a lot of this stuff you guys aren't going to find just laying around, and you're going to have to wait to try to order one, or you're going to make inaccurate diagnostics because you didn't pick up these kinds of stuff along the way. I will say the best tool I've ever bought thus far, I'm going to just tell you the secret tool right now. It's this pressure transducer, because I can tie this pressure transducer and just click it in to fuel fittings on a ISX, the high pressure gear pump. I can do it on a C15 on the filter head. There's a pump for CompuCheck. There's another one on a Series 60 right in between the fuel pump. These fittings are put everywhere because of ease of use, but it's a universal fitting. So you just take this, you put it on your little pressure transducer, plug it into your multimeter, and then you go in the cab and you run it during its load, and you can see what the exact pressure is as far as like actively. So in the substituting a dyno isn't possible unless you have one of these, or manual gauges. So when I ran a dyno at Freightliner, part of the dynos were just using the inputs from the sensors, and the other part of the dyno was to do twice the amount of work by hooking up gauges to every single thing and hooking up manual gauges to a big cluster and monitoring them all and making sure that the data on the computer was matching the data on the actual value for a manual gauge. Because the first step in troubleshooting a value from a sensor is to put a manual gauge on it. This is essentially a Bluetooth gauge. So now I can go and do whatever I want as far as on highway testing, taking active readings, because I have gauges tapped into the system live, verifying my inputs from my computer. So a computer might tell the ECM, hey, we're only at 52 degrees because your coolant temp sensor isn't correct. So on that full dyno, you would put a temp sensor in there and you would verify that they're accurate. And that would determine a whole lot about us fueling an engine as far as cold or hot. And that coolant temp sense is a very big part of that equation for cold starting fuel strategies versus, load, all those. So let's talk about mechanical and electrical pumps. Mechanical pumps usually over time will displace less and less and less, or fail completely and discharge none. Electric pumps, same thing. Sometimes they will depreciate the amount, but sometimes they will just go open, and you can tap the fuel tank on an automotive application, and all of a sudden it'll free up that little winding in there, or the little armature inside of there that's being rotated by that solenoid or pump. And essentially it's just a bunch of metal windings like we showed on those other videos where you have windings, right, in that little spool. And if those windings get a lot of resistance, it doesn't matter if you put the 12 volts to them. If it's cold, that resistance will increase and it will be harder to start. So these are all things to include as far as like, am I dealing with an electric system, a mechanical fuel pump system, and just something to keep in mind. Also, if you're trying to take a straw and suck through it and there's a hole here and this isn't submerged, then I'm going to suck air. And you will find that a broken standpipe inside of a fuel tank will suck air in the fuel tank. And I've seen them crack, And it's one of the most extensive diagnostics just because people don't use a lot of clear hoses. They make a lot of assumptions and take a lot of guesses with people's parts. It's just a fact. Everyone knows it. So, pump parts would decrease. Electric coils, talked about that. So when we start a diesel engine, I told you we have to have fuel prime. So the way that is done is my pump is pushing out 4 pounds. But if the back of the head was a big old hose, it would just push it out. So what we do is we put something in the back of the head where this is bigger than the outlet. And what that does is, let's call this the block. If I put this way, in order for the fuel that's being pumped into the block, right, I can get the pressure in that block where 1, 2, 3, 4 injectors are being installed and all being fed on one rail that goes, fuel rail that goes all the way through the head. So every one of the injectors is being fed on that same common pressure. So if I have something in the back of the head that doesn't create pressure in the head, all those injectors are going to have a hard time because they need to work on a certain amount of fuel pressure. That's engineered into the injector's throw, the hydraulic pressure that's being built, all that. So this can be done a few ways. It can be done by a check valve. It can be done by a limiting orifice, but it's always done some way. There'll be a relief valve from the return. Something has got to slow the return for that fast start. That way, you know, if you didn't have that, you would aerate that whole head and lose prime. Well, you wouldn't aerate the head. What would happen is you wouldn't be able to, you would dump all the volume out and you wouldn't be able to build pressure in the head. That's better said that way. So go up to straw. Remember what I said, there's a long length of hose to get to this pump. It might be 15 feet of hose and every little connection matters. So if you are questioning whether or not it's the pump, the easiest thing I found to do is to take your own hose, get a bucket, fill it with diesel, and route it directly into the pump. And disregard all this stuff over here. Earlier I talked about those braided lines and finding holes and how to find them. What you would do is you would take the fuel line from here and you would put a plug on it. And then you would go to the fuel tanks and you would pressurize the tanks. Sometimes you have to fold over the vents, which is a little simplex line usually to build pressure in the tank. You don't need a ton of pressure. What you just need to see is you won't ever find the suction sides leaking, but you can find them if you pressurize the fuel because it's always suction, it's never pressure. So you won't see it leak under that. It's kind of like AC, will leak under vacuum or leak under pressure, but that's why you put it under a vacuum and under pressure. The vacuum is not just to take out the moisture, it's also to make sure that it holds under vacuum because that seal being pulled is different than that seal being pushed. O-ring, same way. So one thing I want to talk about that I think is worth it is, we'll leave this. 3, 4, 2 fuel used. Yeah. So engines that are making oil. So whenever I have an injector, let's just call this an injector. There'll be O-rings here, sometimes O-rings here. All those O-rings are separating passages inside of the head. Fuel might be running this one, oil might be running this one. Coolant might be running under that injector cup. It's important to understand this about the injector. If any of these O-rings leak for the fuel, that oil will go into the crankcase or it can go down into the cylinder. It just depends on how that O-ring fails. So the easiest way I have found is to take something like this, right? It has the thing on the top, and this is a higher pressure than just, you know, it's able to build pressure for fuel or fluid in a container. And then what I would do is I would take my CompuCheck, and I would put this up like a C15, put it on the head, right there where the fuel filter is, on the fitting. And then I would take the valve covers off, and I would open that valve. You put a shut off like a one way on this, put a hose to my fuel tank, clearly, pressurize it, open that thing, and look and see if, as I feed the fuel rail, which one of these injectors has fuel coming up the sides of it, or which one of the exhaust ports is now starting to get wet. And that's going to tell me if it was inside the head that I'm losing my pressure. So when we're looking at it, let's say it runs off of a bucket just fine, obviously it's in there. But let's say it doesn't run off of a bucket, it could very well be because the engine's making oil by all that fuel not going to the injectors but dumping out past the O-rings. So when we want to, if you are curious, if you have a dipstick, you pull a dipstick, for something that's making oil where you have fuel aeration from O-rings and injectors or something like that, you will have a separation. If you let it sit overnight, oil will be on the bottom, fuel will be on the top, and you'll be able to see through the fuel, and it'll be a clear separation between the oil and the fuel. You have to let it sit. If you mix it up, there's no way of telling. But that's a good way of checking to see if you are, in fact, diluting from fuel, injector O-rings or such. So we check the pressure supply to the head. I told you how to do that. Huey O-rings I'm going to mention. So on a Huey, which is a hydraulic electronic unit injector, I have, just like I was telling you, I have fuel, and then I have oil. But this oil gets to 3,700 pounds. So any leak there can keep the injector from being able to deliver fuel. That oil is used as a high-pressure hydraulic fluid to operate this fuel part. And then the injector coil, let's call this the injector coil. What I'm doing is I'm sending power to the solenoid, and it shuts off a certain part in there, and it allows it to build fuel pressure. Without the hydraulic pressure, it has no way of building pressure on the fuel side. So you won't get fuel. Even though you have fuel pressure, it's not a fuel problem. Fuel is not being delivered because of the oil pressure problem. So on that specific injector, you have to look at not just fuel, but also the oil pressure. So if I have a crank no start, it can be because of, or an extended crank to start, it can be because of a hole in that high pressure oil system is not checking that hydraulic pressure and allowing it to increase. Usually you will see this by ICP pressures, right? So if I wanted to look at fuel pressures, I have a 3-wire pressure sensor video I did. Go back and look at that, and you can see how I sample air pressure. But it's fuel, air, oil, anything with 3 wires and a pressure sensor is always going to operate on that same principle. So I'm going to look at the signal voltage, and I want to increase the pressure to it and make sure it goes up. If I'm on a road test, I want to back probe the sensor, get a multimeter like this, take it in the cab, and watch my signal voltage go from the 0.25 to the 475 smoothly and evenly. I know then that it's not a matter of my signal voltage input, and that it's probably something within an actual mechanical system. So that whole manual gauges things keeps a lot of guys, like I said, from making the accurate repair, because they're not willing to tap into these gauges and sample certain life. Some of them you can't. Some of these things, like the Huey systems and the 30,000 pounds high pressure stuff, unless you have all those Cummins gauges and stuff, and a lot of guys don't, they don't even use those steps in the troubleshooting for the fuel, because it's not even that safe to be tapping into 30,000 pounds of pressure. It'll cut your hand clean off, like in half. So what we do is we monitor the amount of volume coming from those things. Like, here's a good example. So let's say I have a high pressure common rail. I have the rail and then all the injectors being fed off of it. This is the head. This is the return from the head. This is my fuel regulator. I'm going to suck from the tank, through the filters, through the ECM cooling plate, all these points, long time before I actually get to a point where I can build that into a little bit higher pressure and then go up here to the rail. If I take this line loose that comes from the high pressure side of the pump up to the rail and put it into a cylinder, right, a cup, it's going to fill up that cup a certain amount. That is a volume check. That is not a pressure check. They want to make sure that you can deliver the amount of volume up to that rail to maintain that pressure. So the reason why I brought that up is because when we look at these in the 30,000 pounds, the reason why they set up a test inside of the ECM where I can initiate a test for high pressure system leaks is because the only way I could ever see that 30 is if I was on a road test, and that would be, gauge setups and all those things would probably preclude you from doing that. There is a pressure sensor on this rail that tells the computer where that pressure is at, and then this fuel control regulator, AFC ratio valve, lots of different names for them, right? But this valve is about a $280 valve from Bosch, and it's pulse width modulated, meaning the computer is only running it at either 100 or 0%. And each percent will increase the pressure, operating from 7 all the way to 30,000 pounds of pressure on that common rail. Keep in mind, we talked about any kind of leaks in that other fuel system as far as injectors go, but what if I have a leak right here at that thrust nut holding that high pressure connector into the injector? We talked about this on misfires, but it will create an excessive amount of leak back in the head. And the way you test that is by taking a block off. They sell these, Lyle sells these, Snap-on, and you block off these little fittings up here at the rail, and you stop feeding this injector, and then you measure the amount of return, and then you put it back on and then block this one off. Each time what you're trying to do is see which one is contributing to a higher leak back in the head. So if I know that by removing this one, I now have almost nothing coming out of the head, but when I connect it, I have a ton of fuel coming out of the head. Oftentimes it's just that thrust nut that's holding that connector into the injector. It's too loose, so that seat and bevel will be creating a low pressure fuel fault. Sometimes this happens only after it heats up for a couple days. That was my experience on one generator that I worked on, and it was 3 days of operation, and then all of a sudden it would do that. And it was no rhyme or reason why it chose to leak out at that point, but it did. And like I said, if you're not putting those fuel systems together in a very clean way, making sure the integrity is there, when you get up to 30,000 pounds, that's CNC type, blowing holes through metal kind of pressures. So keep that in mind. If you enter into that high pressure test with Cummins, make sure you're wearing something like goggles, all right? So the discharge pressure will drop when there is an open or crack in the injector. So engine making noise, apply the head with pressurized Huey O-rings, injector cups, talked about that. High pressure pump, low pressure pump. So the high pressure common rail stuff is very extensive as far as measuring and testing how much is being delivered. But the reason for that is because there's so many points of failure that if you don't verify each one, it's hard to say. So I've had trucks where I've had to put one small line in place after checking all the others, and found that it was that line that had a little bitty crack in it, and it was the one that was aerating. Or not fitting, but that component was the one that was aerating, and I didn't know that until I took and watched the bubble go across from one side of the ECM to the other. The reason why I'm bringing these things up is because 90% of the problems I find, guys, it's air in the fuel or it's poor filtration. The pumps and the hard parts, they fail when they fail. But the things I found are flow issues, like, okay, here's a good example of pressure issues. Let's look at an ISX engine under full load with the high pressure gear pump there on the side of the engine, the upper middle portion of the block, and that pump is delivering 250 pounds of pressure at minimum. As soon as it gets to, maybe 190 is what I caught one at. 190 you would think is still good, right? But it's not the spec. And when you started demanding the amount of flow that it required for that engine to operate at max load, that it could not keep up the pressure. So, all right. So I'm going to tell, I don't know. Let me just go through here. I have one little thing as far as personal notes, and then we will call it a class. So as far as codes, like I said, most of these don't have fault codes when you're talking about restriction, aeration. They don't always come with fault codes. I will say this AFC ratio control valve is varying the amount of pressure. Now the head can take up to the 30,000, so it's 30K here all the way over to here, 30K here, 30K here. Everywhere there's a connection on that high pressure side is at that 30K. So if I'm looking at that, as far as the high pressure pump goes, I can't discount that it's in the head of the pump, and I can't discount that the pressure isn't being regulated incorrectly by that valve that's varying that discharge. The only times I've ever seen, like I said, that AFC, or I don't know if I told you, but that AFC valve is usually suspect when you have high pressure faults, because there's very few ways that you could have high pressure in there. And there is obviously a valve built in that's called like a pop-off valve inside of that rail in case it does get to some crazy pressure. But and it's also fed by that return on the head. So if you have an excessive pressure in there, it can be because of excessive return flow. But generally speaking, that excessive pressure is caused by that ratio, that Bosch valve. It's got 3 little Torx screws on it. So, filter drop test, we talked about that, but nobody wants to believe it's the filter. Nobody does. And don't let the driver tell you, I just changed the filters, like that matters to you. It shouldn't matter to you at all if you changed them yesterday. If you have a drivability and performance issue right now, we need to start with proper filtration. If you can't take the restriction reading, you need to just change the filter. I've seen thousands of dollars replaced of parts when it was a filter. Guys, really good seasoned guys, the filter was the thing that ate their lunch, and they should have just changed it. So don't be that guy. Change the filter. You will find so much less headache in this whole career if you're just willing to change the fuel and oil filters, or fuel and air filters. Low boost, change the air filter. Pull it out, oh, it looks great, but you can't see light through it. It looks perfectly white, but you can't see light through it. You can't get air through it. So you're not going off of looks. You're talking about, making measurements. There's an air restriction, gauge on an air filter. Why? Because it's only allowed to drop a certain amount. Those gauges don't work for shit. Start with an air filter. Start with a fuel filter. Make sure you lube your O-rings and that you remove the old ones and that you have nice tight seals. Because a lot of times, and I've done this myself, you'll chase your tail over an opening for air that you made when you were trying to start your repair by doing filters. A 6.7 Power Stroke, that little fuel bowl that has the crack. When you turn it too far, there's a stop there. Every one of those, you can hear it as soon as you go to key it on, just sucking the heck out of some air. And it gives you poor fuel operation, low fuel pressure fault codes, erratic fuel pressures. All right, because it's trying to compress the fuel inside that rail or air instead of having all fuel inside of there. No air. Low load, low volume. Big load, high volume. All right, I'm going to reiterate that. You have to simulate the load to measure it. We talked about that. So run it out of a bucket. Talked about that. If it needs to, let it sit overnight if you're running it out of a bucket, because you need to simulate the same type of situation. If the driver comes to you and says, if I let it sit for 2 days, it's an extended crank. It takes a long time to start. Then let it sit for 2 days before you work on it. So manual fuel pressure checks always be used to verify fuel pressure sensor when possible. We talked about that, the PAR dyno. Signal voltage on pressure sensor, talked about that. And then HUE injectors will be our next class. So I think we've covered everything I had intended to cover as far as fuel systems go. And I will say, like I said, get yourself different diameters. This is one thing I did want to drop on you guys. This is what I use to seal. I don't use Teflon tape to seal. I prefer this. I've seen Teflon tape, little strings of it get caught in all kinds of different places in fuel systems, and it's no good. This, I've seen it packed in front of an injector. All right, it's blocking the hole for a fuel supply. So this is a tapered extractor. So if I have a fitting like this, because brass is so soft, if I use one of those other extractors and I pound it in there, it usually just cracks them open and then it makes it more difficult to get out. If you use one that's square, like this, it just pushes on the 4 sides, so when you hit it, it doesn't deform the whole of the brass, and it's really easy to get fittings out when you're taking them off to do your testing. Another thing I will say here is, if you have the opportunity there to get to start putting the fittings together, separate your pipe and your JIC and all the other stuff from the caps and plugs, and then a lot of these fittings you might use only once or twice or whatever on different engines to do different types of tests. But don't discard that tool that you made, because I'll tell you what, those are some of the most valuable tools I own, those little fittings to go and pressure test different things. Some of them like this. This is a compressor sensing line for Detroit, and this fitting is the only one, the fitting they make like this. Volvo uses one like it. It's bigger, but they're both GIC, O-ring Boss, and it doesn't actually make sense, but keep those fittings if you have them. That way, testing will be really easy for you in the future. All right, guys, I hope this class was useful to you. Stay tuned for the next one, and have a good day.